hello.
All right.
Hey, hey. Well, in case you are caught off guard, it is Mustache Monday. Uh, Brent clearly did not get the memo, but
I do what I can.
that's okay. That's okay. Anyway, welcome everybody. So we are doing containers from the couch. I'm Adam Keller.
And I'm
This
Brent Langston.
is Brent Langston. I pointed right. I almost pointed wrong, and I got to you. Um,
Nice.
so today we are going to talk CDK. We're going to build a service. We're going to take a queue service. I've got some code. I've got a Docker file. We're going to take that. We're going to use the CDK. We're going to live code it, and we're going to deploy a queue-based Fargate service. And then if there's time, we're going to deploy a scheduled task using the CDK that's going to constantly feed the queue. So
I feel
yeah,
like there's a joke there. If there's time, we're going to do something scheduled. We should schedule it, right?
that was good. I didn't even think like. See, this is why we're like peanut butter and jelly, Brent. We just work so well together. So
Nice.
that was good. Thank you. Yeah. So assuming there is time, we will schedule a time-based service. We're just going to build it. Whatever. I don't know.
Yeah.
All right. So yeah, should we get into it? What do you think?
I think we should.
Okay. And so today we're going to do this, and then going into tomorrow, if you're familiar, if you follow the CDK, there was talk about a beta feature that was just released with CDK pipelines. So tomorrow we're going to unbox the CDK pipelines functionality, and we're actually going to take our code and that we're building today, and then we're going to put it into a pipeline tomorrow and see how that all works together. So we're going to
Totally.
stitch it all together. So let's
Nice.
do it. Let's get to the terminal. Beautiful. Okay. So let's start with what I have. Okay. I have two files. I've got a Docker file and I have some code. So my Docker file is pretty straightforward. I'm just building from an Alpine upstream image because I want this to be lightweight. And I'm installing Python. And by the way, there is even a better, there's a Python 3 Alpine image I could use, but I'm not. I don't know why. So I'm simply just installing some couple Python modules, specifically Bodo 3 and the AWS CLI. And Bodo 3 is what actually the module I use to talk to the queue service. So this is my code. Okay. And in this code, I just got a couple methods. It's honestly very simple. This is nothing fancy, nothing crazy here. But I look for a queue name in my environment, and I use that to either consume or send to or from a queue. So in the case, what we're going to do now is we want to take this code. I want to build a queue consumer. So Brent, if I were to do this, just forget any CDK, anything that I'd build it with. How would you think about building all this, and what components do you think I need to get all of this wired together?
Well, I mean, there's the question of what are you using for a queue? Um,
SQS. Good question.
SQS, nice, yes. Good because it's a managed service and you don't have to run, your own queuing service. And then yeah, you typically just have something that produces into a queue and you have something that consumes off of the queue and then goes and does some work. So that's really pretty basic, right?
Yeah, while it sounds basic, no matter what, I need an environment to build this in, right? So
Oh, well, yes.
I'm going to
Sorry.
need for my service, I'm going to run it in Fargate, right? So I need to
Yes.
deploy my container somewhere. So I'm going to use
Oh, that's
ECS.
right. We are here to talk about containers. I should have thought of that.
Did you forget? You know what? We'll get a memo going just to make sure we're all on the
That's
same
right.
page for tomorrow.
Yeah. So yeah, you'd want to pop this into a container, and I think queue-based stuff is a really great use case for Fargate because you can scale it as much as you want, as high as you need. And then when you're done and your queue might be like empty or very low, you can scale it back down, and you don't have to have, a bunch of compute hot ready to go to host your consumer or producer, depending on which side of the equation you're on. So I totally think Fargate is awesome for that. Um,
Yeah.
yeah.
And I actually, I swear, everybody watching, I did not feed this to Brent, but I'm really glad you mentioned auto scaling, because
Oh,
no
nice.
matter what, I'm building a service. At some point, when I want to move this to production, I have to consider scaling and auto scaling, right? Like I can't have one consumer or 10 consumers running at all time without having some sort of scaling. Otherwise, I'm just paying for services I'm not using, or I'm under provisioned. So we need auto
Exactly.
scaling.
That's part of being cloud native is just have what you need.
Exactly. Right. Don't pay for a bunch of resources sitting idle. That's crazy. We don't need to do that here. So let's only pay for what we use when we use it. Trade
Yep.
is it like trademark? I don't know. Anyway, okay. So here's my service. This is great. I've got code. It feels really good to have this code, but let's run it locally really quick. I have a. Oh man, hang on one second. Let's do that. Can you hear me?
Yeah.
Okay, and I can hear you too. Sorry, had some issues there.
Oh, okay.
So I have a queue up and running right now, and I just want to show you I'm testing locally. This is just to show queue service. I'm sorry, export queue name, and then I'm going to run my code, and let's send 100 messages. And what this will do is it'll send 100 messages to that queue. And on the right, you can see in real time, I have my same code running, and it's consuming those messages. So that's because I'm simply running the queue service receive, which is what I want to do with this service when I deploy it. Okay,
Cool.
so 2 consumers running, consuming messages. Okay, cool. I've done it locally with the queue in the cloud. This is great. But now let's actually get it deployed. So as I mentioned, we're going to use the CDK. And when you start a CDK project, the CDK command line has an init parameter. And with that, I pass in the language that I want my code, that I want my CDK to be written in. So if you know me, you know I love Python. It's just my thing. Okay, perfect. I'm in a non-empty directory. So let's actually do this. I'm going to move these files out. So you see it gave me a warning.
Oh, because it wants you to start like from the beginning with CDK.
Exactly.
And
Fresh directory.
yep. Okay.
And you can walk through it. Basically, what this is doing is it's creating a skeleton project for me that's going to have all the components I need to get started based off of a CDK best practice. So I ran the CDK init. It also gave me some nice output of ways to work with the CDK. This is all in the README that comes with it, by the way. So it's all there if you want to reference it. So one thing also is it recommends building in a virtual environment. With Python, it's good to build in virtual environments because you don't mess with your Python packages globally. I can build them locally and test if different versions in my local environment. So that's with
Yeah,
virtual
because
env.
you might be initializing this at CDK version X, and then 3 months from now you'll be at CDK version Y, but you'd still want this to run the way it ran when you first built it until you get around to updating the libraries and stuff like that. So that's a way for you to like sort of pin all your dependencies into the version that they need to be at the time that you're doing this.
Exactly. So again, it gives me this nice kind of base skeleton structure here. And actually, when I initialized it, I had 141 installed. Let's do this with, let's actually update. I don't want to use the older version. I want to use the latest version of the CDK. Let's see how that
Wait,
goes.
so you're doing this untested, right? Like
Untested.
obviously.
Untested.
Doing it live, folks.
Listen, there's no better way than to just do it live. And yes, Brent, you're absolutely right. This is completely untested. So let's go with.
We may not get to that scheduled service later. We'll see.
It's just, CDK moves fast. So this
That's
is
true.
another reason why testing in virtual environments is so important, because you may have on your file system, globally you have 141, but we're already on 153. So you may want to test the different changes in that virtual environment.
Totally.
Okay, so we're going to install the core package, and then I just want to install the AWS ECS patterns module. So this module right here is a set of patterns, best practices, all built into high-level CDK constructs, AWS CDK patterns. And let's actually look at this in the construct library. So here's the docs. There's a set of patterns. We have an application load balance service, all these different kind of predefined, pre-baked constructs. Here's the cool thing about working in the CDK when I'm using these constructs. I can build off of the best practices and use the opinionated nature of the CDK, or I can customize these high-level constructs to fit the needs that I need. So an example would be, if I don't want the construct to create a VPC, I can import a VPC and just use that in my construct, and so on. So I have customization, and when we get into auto scaling, I'll actually show that as well. Okay, so we have this. Let's actually now install. We're going to install our requirements txt, which is basically just saying we want to install these packages that I just defined, or these modules defined in my setup py. And as questions come up, by the way, please feel free to put them in the chat. Brent will pop them on the screen.
Yes, for sure. Drop your questions in chat, and I will make Adam answer them.
Or I'll do my best. No guarantees. Okay, so what generated for me here was an app.py. So this is essentially where we are instantiating our CDK app. And we're calling from the AWS CDK module. We're calling the core module, which is where all the core functionality within CDK lives. So we're instantiating our app. We're then passing that as scope to our queue service, which we're going to build in just a moment. And then we're synthesizing. So in the CDK world, when you synthesize your code, what that's doing is it's taking all the code you've written, converting it to CloudFormation behind the scenes, and validating that everything that you've defined in code will actually output to a CloudFormation template. So we'll show an example of that in just a moment with the command line, but that's essentially what we're doing with that synth command.
And this is where the synth command tends to be where you'll catch like a lot of your syntax errors and stuff like that, where you might have messed something up. Exactly.
Okay, so we got a lot of stuff here. Now what I want to do is I want to get this built. So here we have this is our service stack. Now when we think stack in CDK, if you're familiar with CloudFormation, a stack is just a representation of your environment, or those components within your environment. So I'm going to import the AWS ECS patterns module, because that's what I'm going to be using. And now let's just get started and start building this. Okay. So we're going to call the AWS ECS patterns dot, let's see, queue processing Fargate service. So you can see I have my code completion here.
Yeah, I was going to say code completion there is pretty awesome.
It's super nice, and I got to tell you, it makes working with the CDK a lot easier. And this is, again, the benefit of using the CDK. I get to use my IDE, all my bindings native to my programming language that I like, and code completion. That's super nice to have. Yeah. So we're going to define our CPU. I'm going to go with a half of a vCPU. And then we're going to define our memory limit here, which When I tested, I wanted 2048 just because I don't know why. It was just kind of a heavy image, and processing a queue took a lot of work apparently. Okay, here's the cool thing. This is probably one of my favorite features with the CDK. So I'm going to define my image. Let me also import AWS ECS module. Because as I build in the CDK, oftentimes these parameters I'm passing into my my main construct that I'm working with, there's oftentimes other constructs that I'm calling to pass into the parameters to that construct. And the idea is these constructs wrap a lot of the heavy lifting and a lot of the boilerplate for me. They take care of a lot of boilerplate. So I just call the construct, define what I need, and the CDK will handle the rest. This is an example of calling the container image construct, and I'm going to say from asset. Brent, what do you think it's going to do here when I say from asset?
I think you're going to be able to point it at the Docker file and have it like figure stuff out.
Exactly. Exactly. So, Brent, remember in the old days when we used to run Docker build, Docker tag, Docker push?
Yeah.
Yeah, I don't have to do that with the CDK. The
Okay,
CDK
that's
will
pretty
do that
cool.
for me. So these are just, go
And you
ahead.
don't have to like have one thing pointed to another thing that's like it knows whatever directory, look for a file name that is Docker file with a capital D. So that's actually going to be really awesome. You don't have to like make sure that it's named the same in two different places that aren't actually related to each other or anything like that. So yeah, I'm liking this so far.
And okay, let's say in the world of a mono repo, you have 100 Docker files here.
Oh,
Okay. I could say Docker file dot whatever my actual file name is. I could actually point it to a Docker file as well.
because all the defaults in the CDK, well, maybe not all, I assume, usually the defaults in the CDK are overridable, right? So
Exactly.
that's just a parameter that you decide I'm going to customize this because I know better than whatever the default is in the construct.
Exactly. Bingo. So so that's it. So by just simply saying, now I could have pointed to an upstream image. I could have pointed to like ECR. There's a lot of different functionality within the image asset, but I wanted to build it locally and let the CDK handle that. So that's what we're doing here. Now, the other thing we're going to set is desired task count. I'm going to say 1. I don't need a whole lot. But here's the override functionality example that you have with the CDK. That sentence, by the way, was really crazy and didn't make a whole lot of sense. So by default, auto scaling is built into this construct. This construct will create a step scaling policy based off of how many messages are in the queue for a certain period of time.
Hmm.
Meaning, if you're over 100 messages for over 5 minutes, the CDK is going to build an auto scaling configuration that will bump your service up to 2. The max count is 2 with the defaults. So that's cool, but I want a little more. So this is a way that I can actually override, and I could say max scaling capacity equals 10. So
Again, overriding the defaults for the construct. So
yep,
when you know better, then it's absolutely awesome that you can do that.
exactly. And that brings up a good point. When you know better, and not to say that you don't know better. I'm sure you're really smart and awesome, but we don't know everything. And oftentimes, if this is, especially if we're coming into this relatively new, not working with SQS and Fargate, deploy the defaults, work with it, test it, and then as you see you need to customize, you can. So,
Exactly.
all right. So that's it. So we've written our code. And as you can see, that was a lot of work. I think this is 10 lines of code. And when I say 10 lines of code, I am counting the parentheses. So we have 10 lines of code that have defined our CDK app. So now what I'm going to do,
So you
damage.
haven't gone and built an ECR registry or an ECS cluster. Like, what do you have built already?
Nothing. Not even a VPC, not an ECS cluster, not an ECR repo, as you said, which by the way, we're going to see what this does because that's a great lead in. And I don't have anything built right now. I mean, I have another environment, but that's not what we're building right now.
Yeah.
You know, so there's nothing right now. So let's do it, huh?
Yeah, let's do it.
So the first thing I'm going to run,
Let's check your work.
and let's see if it works with the latest version of the CDK.
Exactly.
So perfect. It can't find the Docker file because
That's
I don't
right. You
have the
copied
Docker
those
file.
out to initialize.
And then qservice.py here as well. And actually, let's go to my Docker file.
I was about to say, can you show us your Docker file?
Yes, let's do that. So, oh, you know what? Sorry, don't save. Vim Docker file. Okay.
Now you're showing off. If you didn't catch that, folks, he aliased Vim to C9 open so that Vim would open in his Cloud9 IDE, which is awesome.
Yes. And thanks to Richard Boyd for telling me about this, because this was one thing with Cloud9. I'm just a Vim person. My default is Vim file, and I want to edit. So we alias, and the alias is a colleague of ours, Ali Ardestani. He gave me the tip. So I don't want to take credit for anyone else's work here, but yes, that's what I did. So, okay. So I am now, yes, I love the little tricks too.
Yeah, like, totally.
These are the things that just make it easier and fun working here. So, okay, here's our Docker file. I'm copying that qservice.py code, which is what we went over earlier, which I'm just reading the queue. And you see my command in the Docker file instruction is to, when the container starts up, it's going to run qservice.py and pass in the receive parameter.
Yep.
So it's just going to be consuming. So my files are there. Let's cross our fingers and hope I didn't break something. And actually, I'm running a CDK diff, which is okay. I wanted to run a synth first.
I was about to say, this will synth for you and then diff, right?
Exactly. So let's just call this like a sneak peek. Let's go back again and run a CDK synth. Pretend you didn't just see that. We're going to go up here. And okay, so CDK synth, what it does is it gives me an output of all of the CloudFormation that my code was compiled to. Anyone want to guess how many lines of code this is of JSON?
I'm going to throw a guess out there, 607.
607. Chat, any guess? I'm going to give it 10 sec. Actually, there's like a slight delay.
There is a delay, so we have to like wait to see if anyone wants to throw a number out.
Oh man, the suspense is killing me. But
actually, while we're delayed, there was a question in chat that you can potentially address. Here we go. How does Adam keep such a beautiful mustache fresh and well groomed?
You know, I appreciate that question. This mustache went through a lot of work to get here.
It's iterating, right?
It's constant iteration. When I started out, Brent earlier saw me, it was like this, and I wasn't super pleased with it. So now we've gone to this. I don't know what you would call it, like a Freddie Mercury mustache, maybe?
Yeah, I think I would totally understand what you were talking about if you said that.
So, but thank you for the, I call it Mustache Monday. I think I'm just going to do this every Monday. Thank you. Thank you so much, Anton. I really appreciate the kind words.
I can't do it.
You can. You got it there.
Cholmang says 1,000 is his guess. I say 607.
And it's 674.
Whoa.
So close.
I mean, I was completely guessing.
So in the world of The Price is Right, Brent, you would win. Cholmang, you would lose.
That's right. I'll see you in the Showcase Showdown.
So, okay. So 674 lines of JSON that I don't have to worry about because I defined all of that in 10 lines of Python, which is what I enjoy doing and what I'm more comfortable doing. And by the way, I can unit test this Python too. So I can
That's
build
right.
standards into my code that it's more difficult to do with JSON. 674 lines.
And it's
Let's
and it's only like the lines that are the 10 lines that you typed in are the ones that you cared about. They're the ones that matter. You had a need for scaling all the way up to 10. And, I don't remember what else you had in there, but the point is like those are the ones that mattered, right? So you're only focusing on the high value content.
exactly. So we have now, okay, so that was a CDK synth. Cool.
Yep.
My code compiles to CloudFormation. Now we run a diff. A CDK diff is going to take a look. It's going to create essentially a change set. It's going to say, what do you have presently deployed in the environment with this stack name? And then let's compare what changes you're proposing. This is very similar to I'd say like a Terraform, like in Terraform when you run like a state diff.
Yep. I was going to also throw out there, for those of you that are still relatively new to the CDK, they just announced late last week, if I remember correctly, that in beta or preview, I don't remember if there's let's call it beta,
Yeah.
you can now output to Terraform instead of CloudFormation. So I think that's pretty amazing too, to be able to sort of choose, still have this rich programming interface to be able to build your infrastructure, but then as far as like executing it, have that, roll out some Terraform code instead of just CloudFormation being the only option.
Yeah. And that's pretty amazing. So the CDK has gone from an AWS tool to build CloudFormation templates and deploy them to the open source community for outside of CloudFormation with Terraform. And we have CDKs if you want to deploy
Yep.
your Kubernetes templates, your Kubernetes YAMLs using code. So it's just growing, and the functionality is crazy already. So it'll be exciting to see where it is a year from now.
Yeah,
Okay.
absolutely.
So I ran a CDK diff, and basically I'm creating all new stuff. You can see all the resources I'm creating. What's nice is it always, if you're changing IAM, anything in IAM, or you're changing anything related to security groups, you will see those reflected at the top. And it's going to tell you exactly what you're changing. Which, Brent, pop quiz, how many IAM policies and roles did I have to create when I wrote this code?
Well, you did not
Me.
have to like do anything to address IAM yourself, but I know that there would need to be one for your container. It would need to have permission to be able to read from the queue. Um, there would need to be a policy for ECR. Um,
Yep.
Gosh, I can't think of what else.
Logs, logging.
Logs. Thank you. Yeah,
Yeah.
logs.
Yeah. So all of these things. Now, I think IAM is super powerful, but it's also relatively complex and you can get really deep with it. So I'd prefer someone that's smarter than me at IAM to just do this for me. And that's the CDK, because CDK is going to connect this construct's connecting my service in ECS to that queue with very limited permissions, only the permissions that we need. And actually, it's like, it's not full admin. It's just the ability to write or to read or write from that queue. So
Nice.
very limited. All right. So
Oh,
we
I
see all
just
my
thought
changes.
about the
Yeah, go
queue
ahead.
doesn't already exist either, does it?
It does not. But if I had a queue that existed, guess what? I could pass that in.
Nice. Okay. Very cool.
So now it's deploy time. So I'm going to run CDK deploy. I'm passing require approval never, because what would have happened was it would have asked me to approve the security changes with IAM and security groups. So as you can see, I ran the CDK deploy. Look, it's building my Docker file. It
That's
pushed it to
awesome.
ECR. By the way, so it pushed it to ECR, a repo that I didn't create. CDK created it for me. It also tagged my image, Brent.
I was about to ask, how did it tag your image?
And so it tagged it with the git SHA, right? Which is generally
Awesome.
when you're deploying images into production, you don't want to run off of latest. You want to have some pointer to that artifact. Awesome. I love that I've already caused a failure here. This is because I have too much going on in my account. So we're going to go to CloudFormation. At AWS, when you work here, they give us very limited accounts.
Yeah.
Limited, things to do within the accounts. So let's.
Of course, you say that with like 10 CloudFormation stacks. So, but yes, folks, they are generally pretty limited.
Totally fair, Brent. Totally fair. I'll allow that. I accept that. Okay, so let me just delete some stuff in CloudFormation here. This is why I love this show, because we demo things live, things break, and that's okay, because realistically, in the real world, things are going to break.
Absolutely.
So in this example, I just actually hit an account limit, where now if you as a customer hit this limit, you would simply go to increase that limit for your account. But in this case, it's a lot harder for me to do that, so I'm just going to delete some stuff.
Yeah,
it's much easier for me to do that. So
I also switch regions. That's another fallback if you wanted to do that.
That's a great idea. I think I'm going to do that. So let's do that. Actually, that is way better. And
if you really want to go out on a limb, use San Francisco, because I know you've probably never used that before.
That's a good point. So that's a very good point. So let's do that. So here's what I'm going to do. I'm going to pass in to the environment here. That was such a great idea. US West 1. Okay. So we're gonna,
this whole doing it live thing, we're gonna really put it to the test today.
Yes. All right. So let's. I have env grep CDK default. I don't have it set. So let's do this. Export. So when you start to work in different regions, the CDK wants you to be a little more explicit. So I'm passing in the account and the region that I want to deploy to via the env parameter. So what I'm going to do here is AWS STS get caller entity. We're going to pipe it to jq.account ID. Is it just .account?
I think it's account ID.
Echo CDK and grep CDK. And there it is. I just don't want quotes.
Yeah, JQ-R.
Perfect. Okay, so now we got it. There it is. Beautiful. So that looks good. Now let's run. Now we're going to pass env equals. Now we're going to do it again. We're going to run a CDK diff, and let's see how it works.
Yeah, do you have to like resynth?
Well, so if I were to just go straight to a CDK deploy, it would do the synth for me.
Okay.
Okay, just forgot an import there.
Perfect.
Oh my goodness. I am just sorry. Environ. There we go.
I mean, your IDE was telling you.
I tend to not listen to the IDE, which is like, well, then why do you use an IDE? I don't know.
You really just should use Vim.
It's no joke. Just Vim on an old school terminal.
An alias Vim.
All right. So let's see. I think we're good now. So let's run a CDK deploy. Require approval, never. And now what we'll do is we'll switch to, once that starts deploying.
Yeah, let's make sure. Oh,
we got to bootstrap it. So when you bootstrap, this is basically, it creates an S3 bucket with some assets that CDK will use when deploying to that particular environment. So that particular account/region.
So you had already done, and that's for all CDK usage for that account and region, right? So you only do it once for the account and region.
Yeah. But you could, like, if you wanted to bootstrap, and, to be honest, I'm not even 100% sure on all the functionality you can do with the bootstrap. But I think you can add more customizable, like there's customizations you can add to your bootstrap for your particular environment. So you can bootstrap multiple times, I believe. I'm not 100% on that. Okay. So now that we've wasted 10 minutes of me being sloppy, let's get
No,
it
we're
deployed.
learning. We're learning. These are all good
Exactly.
learning moments.
Exactly. All right. So it's doing that again. It's just building everything I need. So let's see. Oh, cool. So in all that time I was talking, I could have just redeployed here because that old environment deleted.
Well, if US West 1 doesn't work out, then we can come back.
Exactly. But so another cool thing about the CDK is I can, when I'm creating a VPC, I'm creating certain elements, and I let the CDK use the defaults, it's going to build in multiple availability zones. But if you're at a region that, do we even have regions anymore that have 2 AZs?
The one you're using does.
I swear I thought we added another AZ here. I could be wrong. No? Okay. So it recognizes that I only have the 2 availability zones. So it's going to deploy to 2. And another thing is, if I don't explicitly pass in these environment values here, it's just going to go with, by default, 2 availability zones. So if I want 3, I have to pass the environment parameters, and then I could also define that when I'm building. Okay, so it's going to take a few minutes because what this is building is a VPC. So it's building our network, internet gateway, NAT gateways, everything that I need to run in our isolated network of VPC. It's building the IAM policies, the roles, the SQS queues. I mean, it's a lot of stuff.
Yeah.
So, and everything you see happening here in the CloudFormation console is what's happening in my command line output here. So that's going to take a few minutes because it's deploying a VPC. That's usually the part that takes a little while. It's whether you're deploying a VPC, the network, or usually load balancers take a little while too.
While we're waiting, let's chat for a second about that whole Terraform output thing. I was thinking about that when you were just talking about bootstrapping the CDK. I wonder if you're outputting Terraform, if it's able to, you know how Terraform you have to manage state, and a popular way to do that is to use an S3 bucket. I wonder if there's an element to the bootstrap when you're going to output and use Terraform, if it will build that state management for you into the bootstrap bucket. Or maybe it does, its own other bucket for managing state. But still, like, I wonder if it knows this is necessary and it builds it for you. Should we explore outputting to Terraform on a future show?
I think so. I think that would be cool. And so I think after reviewing the Terraform CDK stuff, I believe it doesn't actually do any of the Terraform logic for you. It's just like CDKs. I think it's just building templates for you.
Gotcha. So then you would still have to Terraform apply.
Exactly. I believe. And so I'm not 100%, but I do think that's a great idea. We should do an unboxing of that.
Yeah, I like that. I think, let's see. So I know we have another show planned for tomorrow where you're going to continue this, and we're going to look at having CDK build its own pipeline. So that'll be pretty cool. But then after that, did we have anything planned? Maybe we should unbox the Terraform functionality.
I say we do it. I love it. Let's have some fun with it.
We could even make this kind of a whole week of CDK by then exploring CDKs on Thursday.
Whew, I like it. Let's do it. It's CDK week here at Containers from the Couch.
Nice. All right.
So, all right, we got our queue, and you'll notice it also created a dead letter queue. So again, just best practices, right?
Yes.
did that for me. So we have our queue running. Now let's go to ECS. And what we should see is an ECS service that's already in the process of coming up. It's actually maybe running. And I have no messages to the queue right now. So let's put some messages in there so we can start to see some log output. Also, did you notice earlier that I used an environment variable when I was making that call? The CDK automatically gives me that queue name as an environment variable to my task in ECS. So
oh yeah, nice.
They've thought of that for me. Like, how thoughtful of them to do that.
Yeah. So it's not just wired together like hard coded or something like that. They knew, you drop environment variables in for these containers. So they just did that for you. That's awesome.
Yeah. So that's just another cool thing. So let's go export queue name equals this. US default region equals US West 1. Okay. So we have, let's run the queue service pi and let's see if we can send. Pip install photo 3 virtual environment, ladies and gentlemen.
Mm-hmm.
So now let's do it again. There we go. I just sent 100 messages. And actually what I'm going to do is I'm just going to wall true. Let's do it here. That's okay.
Oh, you're gonna load it up.
Yes. Queueservice.py send sleep 2 done. All right, so this will send 100 messages every couple of seconds. And what I want to see now is here's my queue service. We're going to start seeing some auto scaling.
Nice.
Okay. And so let's actually, first of all, let's drill down in the service. Let's see if we can actually see some. There they go. So there are the logs. So our service is consuming the logs, and I had code. I had a Docker file, and through the CDK with 10 lines of code, was able to deploy 674 lines of CloudFormation to AWS, which built all that for me.
And assuming this auto scales, you will have an auto scaling consumer that is tracking based on queue depth, which is a very common way to auto scale consumers. Has it scaled up yet?
I don't know if it's scaled up yet. Let's actually. So
it's pretty quick. So
yeah, here's the alarm. So it's, let's see what the 5 minutes. So okay, it's going to take a few minutes.
So Kun3 Fee is excited, and so is Chilmang. It's awesome.
So yeah, by the way, these are, I think I'm familiar with these folks. They're
regulars on Containers from the Couch.
They may even be regulars at AWS. I'm not sure, but
nice.
Anyway, all right. So this is going to take a few minutes for that to come up. But what I'd like to do actually in the meantime is let's deploy a scheduled task really fast.
Okay.
What do you think?
Yeah.
All right, let's do it.
So now you're going to deploy the producer side, is what you're saying.
Exactly.
Okay.
Let's go scheduled task. Okay, CDK init. Language, my favorite, Python. There is support with CDK for JavaScript, TypeScript, Java, .NET, and and then Python. So if you don't like Python like I do, first of all, shame on you. Second of all, I'm just kidding. Second of all, you get to pick what language out of the handful of languages available. So you're not stuck with using one. And this is all because of the power of JSII, which is the underlying framework that converts everything to TypeScript, I believe. And then that's the base of how CDK is built. Okay, so we're going to do this really fast. We got this. This looks good. So I'm going to keep that. And then we're going to copy the Docker file from queueservice.py here, and then also the Docker file. here because I'm using the same one.
Did you init already? I may have missed that.
I did. I moved really fast because
That's
of time.
cool.
So let's do this. And actually, you know what? Just because of time's sake, I am going to schedule task. Forgive me for doing this, but I already have the code pre-baked. So let's just take this code and we'll copy and paste it here. And I'm going to tell you what we're doing. Okay.
Cool.
So we're importing, we're creating a scheduled task. So we're using the scheduled Fargate test construct. I'm saying, here's my, same thing, here's my Docker image as before. Here's my command. Now, if you notice my Docker image, the command is to run q service pi receive. So I'm overriding the command with send. And then as an environment variable, I'm passing in the queue name, which, and rep queue. Oh, no, I don't have it there. Let's go here really quick. And so if we go here, I'm going to just grab that environment variable. And I'm sorry, it's right here. Okay, so I'm passing in the queue name as my environment variable, and then I'm defining my schedule. So this is a scheduled Fargate task. So every 60 seconds, the ECS scheduler is going to spawn a task to run whatever it needs to run, which in this case, it's going to basically generate 100 messages every 60 seconds. So let's also stop that over there. Okay. And then this, oh, so this is another thing. So this is another really awesome function of the CDK is, let's go to that queue really quick before I explain. And I hope I'm not boring you folks. I'm moving a little fast because I want to try to get this in. But what I want to do now is I want to get this schedule task access. So if you are familiar with AWS and you've worked with it for a while, you know that resources in AWS, it's all least privilege, right? Mm-hmm. You don't get access to anything automatically when you build something. You have to explicitly grant that access. So with the CDK, I'm importing the queue. I'm creating a queue object. And from that queue object, I'm going to call one of the these attributes that, and this is actually using a grant feature, which is going to grant access, hopefully in a good way. Your head's spinning. I don't know. I'm sorry if it's
we'll recap.
But so what I'm doing is I'm saying, here's the queue, grant access to my Fargate service through this object. So instead of creating an IAM policy and figuring out how to connect all the pieces and setting principles and all that, I make one call to just grant that access. That's it. So let's get this deployed. And we'll have a scheduled task very soon. US West 1. Let's see. I'm sure I missed something because I moved so fast. Let's see. There's got to be something I missed. Oh, that's scheduled task stack. Let me just make sure. That's why. Okay, because I copy pasted, copy pasta. And I have a feeling it's going to want, yep.
Yep.
From OS, import environ.
Yep.
Did I set this here?
While you're typing, I'm going to, we had a couple questions pop up, so I'll see if I can address them. You just keep going. So Krenan says, what benefits do I get when using ECS Fargate versus Lambda? They both have their strengths. They're both serverless. One, Fargate is, you could think of as being sort of more throughput friendly because the service doesn't have to tear down and build back up. on every single transaction. So Lambda is certainly going to be fast at doing that, but it's still, there's a bit of a cost for doing that. So if you're wanting, a solution that can scale to zero and only be available or only be active when there's something in the queue that needs to be processed, then Lambda is actually uh, excellent for that scenario. If you always have something in the queue and you're just worried about, keeping up with peak demands, but you're always processing something, then Fargate is going to be there, and you don't have to think about it or pay for it in terms of transactions per se. Instead, it can just sit there and churn through as many transactions as it can. And then if, the queue depth gets to be over a certain threshold, like what Adam has built here, then it'll scale it up and it'll, continue to process even more transactions per second. So yeah, that's kind of how you can think about it. If you want to be um, uh, throughput focused, then Fargate might be your better choice. If you want to be transaction focused, then Lambda might be your better choice.
Yeah. And so in that time when we were building everything up really quick, you can see it scaled up. So
Nice.
it went from 1 task to 6. And if we look at the auto scaling for this particular service, what you'll see is the auto scaling has actually defined that when we're above 500 messages, it will actually add 5 tasks for each data point. So now what we should see is, again, 5 more tasks that'll be added. It'll actually be 4 because it'll get to our max count of 10.
Yeah.
But that's what, and this will scale down too, by the way.
Yeah. So there was a question also, follow up. Worry21 says, can this solution also scale down to 0 ECS tasks and then spin up new ones when the messages come in? I think the answer is yes. There's a minimum and a maximum that you can set, and I'm guessing the minimum is by default set to 1, but you could override it like Adam did. He overrode the maximum. You could also override the minimum and set it to 0. However, just be prepared for the startup time that it takes. So that's another difference between Lambda and Fargate is when you're at 0 with Lambda, when a transaction comes in and you want to react to it, startup time is pretty fast. In Fargate terms, it's seconds. So like it's several seconds, but it's still going to be measured in seconds. So as long as you're okay with that kind of reaction time, then yeah, you could totally scale it down to 0. But we generally like to see scaling down to 1, so that there's always a resource on tap ready to respond. Because then the response time can be single digit milliseconds. It's all up to your app, your container, what language you chose, and all that stuff. And then if you need to scale up past that, you totally can. And you don't pay per transaction with Fargate. You pay per the amount of resources consumed. So with a relatively small Fargate container sitting there, you'll just be spending pennies per hour to have that. So it's worth probably having that additional resource there ready to respond.
Yeah, and so you can see it's scaled out to 10. So
Nice.
it's already scaled within that time. The service has I threw 5,000 messages in the queue, scaled all the way out to 10. If I wanted this to be 100, it could be 100. Like we can go as high as we need. So
Exactly.
anyway,
So
so yeah.
Texan Raj asked, "Can you share your GitHub URL?" Sorry, I joined late. Definitely go back and watch the video archive if you want. I'll drop that URL into the chat one more time. And what are your plans for publishing this code that you showed us today, Adam?
I'm actually glad that you mentioned that. I'm going to post this here, Brent. If you can just, let's see, share this. So I'm going to be doing a tech talk at the end of the month. I believe it's on the 30th. And I'm going to go over these patterns. So I'm going to actually deploy an application load balance service and this. In that tech talk, I will have the GitHub URL. I will release it then. So it's basically just three services: application load balanced, queue based, and then a schedule service.
Yeah. So here's the URL for you to sign up for that tech talk, and you'll be able to see this kind of this in operation, and then Adam will be there to field questions.
Exactly. And so we deployed our. Let's see if it actually finished. Yep. So I deployed that scheduled task, and if we go to ECS, so just another like really nice functionality within the ECS console is all my scheduled tasks are stored somewhere. If I refresh, am I in the right cluster?
Are you in the right region?
Oh man, did I deploy to the?
No.
I think I may have deployed it to the wrong place.
No, I think you did deploy it to US West 1.
Let's just see.
Okay.
If no. I'm sorry. It deployed to a different cluster because
Yes.
it created that cluster for me. But I still think it maybe did it to Oregon because I probably wasn't paying much attention. Yep, there it is.
Nice.
So I got a service running in Oregon. I got a service running in San Francisco. We're just doing it everywhere.
Well, let's talk real quick. Would you have to have it in a different or in the same cluster? And really, the answer is no. There's no limit to ECS clusters or anything like that. ECS clusters are a logical construct. So you can, put things in, if you want them to be grouped together, you can certainly group them together. And if you're going to have east-west traffic, then that would be the way to go. But in this particular case, having a producer talking to a queue and then a consumer consuming off that queue, they don't have to be in the same cluster. It probably would be best if they're in the same region, but that's not, as we see, that's not even necessary.
Yeah, it's totally not necessary, and I like if you can separate, cluster per service. I love that kind of having that isolation. If you're like a service-oriented architecture, you have one team has their own cluster, another team has their own cluster. That's really cool. And it's up to you how you want to build it. That's the nice thing. So to wrap up, because we're running low on time here, we deployed a queue service using the CDK with 10 lines of code. We also did the same with a schedule task that was feeding our queue service. Tomorrow, what we're going to do is unbox the new CDK pipelines functionality, which was just released. It's in beta, so we're going to unbox it and put those two CDK apps into the pipeline and see how it works and have some fun.
Right on. All right, we will see you guys back here tomorrow, same time. Thanks, everyone.
Thanks, everybody.